When we close our eyes and imagine a desert, our minds almost instinctively conjure up images of rolling golden sand dunes, blistering heat, and a sun that beats down relentlessly. We think of the Sahara or the scorched earth of Death Valley. But what if I told you that the largest, most extreme desert on our planet looks nothing like that? In fact, it looks like a world frozen in time. Welcome to Antarctica. It is a land of white, not yellow, of ice, not sand. But make no mistake, despite the millions of tons of ice you see before you, this is a desert in the truest scientific sense. Today, we are going to deconstruct the myth of the frozen continent and understand why Antarctica is a desert. To understand this continent, we first have to unlearn what we think we know about geography. We need to look at the scientific definition of a desert. It isn't about how high the thermometer goes, it's about water. Specifically, the lack of it. Scientifically, a desert is defined strictly by precipitation. Any area on Earth that receives less than 250 millimeters, that's just 10 inches of precipitation annually, falls into this category. The key factor here is aridity, or extreme dryness, not temperature. It is a common misconception that deserts must be scorching hot or covered in sand. The reality is that cold deserts exist, and from a climatological standpoint, they are just as valid as their sandy cousins. Aridity is the great equalizer. Let's look at the family tree of deserts. We generally categorize them into two main types. First, we have the hot deserts. These are the ones you know well, places like the Sahara in Africa or the Mojave in North America. They are characterized by high temperatures, sand dunes, extreme heat, and minimal rainfall. But then there is the second type, the cold deserts. The most famous examples are the Gobi Desert in Asia and, of course, Antarctica. Instead of sand and heat, these are defined by freezing temperatures and landscapes of ice or bare rock. Yet, despite looking like opposites, both types share one critical unifying trait: a severe lack of available liquid water. Let's talk numbers, because they are truly staggering. When we analyze Antarctica's annual precipitation, we see a distinct pattern. If you are standing on the coastal areas near the ocean, you might see about 200 millimeters, or 8 inches, of snow accumulation per year. This is because the ocean influences the air, providing slightly more moisture. But as you journey inward toward the South Pole, that moisture vanishes. In the vast inland areas, the continent receives less than 50 millimeters, that is less than 2 inches, of precipitation annually. To put that in perspective, the interior of Antarctica is actually drier than the famous Sahara Desert. It is a parched wilderness disguised by ice. We often call this place the White Desert, and its scale is difficult to comprehend. Antarctica is the single largest desert on Earth, covering a massive 5.5 million square miles. If you took the Sahara Desert, the Arabian Desert, and the Gobi Desert and stitched them all together, Antarctica would still be larger. And yet, unlike those other deserts where the bedrock is exposed, here, 98% of the land is buried under thick ice sheets. It creates an optical illusion of abundance, a landscape made of water that is, paradoxically, dry. This brings us to one of the greatest ironies in the natural world. It's the case of water everywhere, not a drop to drink. Antarctica holds approximately 70% of Earth's entire freshwater reserves. Think about that. Nearly 3/4 of the planet's fresh water is sitting right there. However, it is all frozen solid in massive ice sheets, making it completely unavailable as liquid. For a plant or an animal trying to survive here, this creates what biologists call a physiological drought. Even though they are standing on ice, there is no liquid water available to drink. Because frozen water cannot support most forms of life, the environment is as hostile as the driest sand dune. So why doesn't it snow more? The answer lies in the physics of the atmosphere, specifically humidity and air pressure. We have to look at the properties of cold air. Simply put, cold air holds very little moisture or water vapor compared to warm air. Because it is so frigid, Antarctica has extremely low absolute humidity levels year-round. Furthermore, the continent is dominated by high-pressure systems. Persistent high-pressure systems sit over the pole and effectively push moisture and storm clouds away. This dynamic keeps the skies eerily clear and ensures the atmosphere remains exceptionally dry. The role of temperature here cannot be overstated. We are talking about extreme cold. In the inland areas, the average winter temperature plummets to negative 81 degrees Fahrenheit, or negative 62 degrees Celsius. These temperatures do more than just freeze water. They stop the water cycle in its tracks. The cold prevents evaporation, effectively disrupting the normal cycle of rain and renewal. When snow does fall, it behaves differently than anywhere else. It does not melt at all. Instead, it compresses into ice over thousands of years, slowly building the ice sheets we see today. If you want to see the ultimate expression of this dryness, you must visit the McMurdo Dry Valleys. This is the driest place on Antarctica, and arguably the driest place on the entire Earth. It is a landscape that defies logic. No snow or ice covers the ground in these remarkable valleys. They are bare, brown, and rocky. The dryness here is ancient. Scientists estimate that rain has not fallen in some parts of these valleys for nearly 2 million years. It is an extreme example of desert conditions existing in the polar regions, a place that looks more like Mars than Earth. One of the forces keeping the dry valleys and the rest of the continent so parched is the wind. These are known as katabatic winds. The definition of a katabatic wind is high-density cold air flowing downhill purely due to gravity. As this heavy air slides off the high polar plateau, it picks up incredible momentum, reaching speeds over 150 miles per hour. That is hurricane force. These winds have a profound drying effect. As they blast across the landscape, they evaporate all moisture they encounter. They effectively scour the land dry, removing any trace of water vapor and leaving bare rock in their wake. In this environment, physics behaves in strange ways. We see a phenomenon called the sublimation process. Usually, ice melts into water, and then that water evaporates. But here, we see a direct transformation. In Antarctica, ice often turns directly into gas or water vapor, completely skipping the liquid phase. This process is called sublimation. Because it skips the liquid melting phase entirely, the ground never gets wet. This mechanism keeps both the air and the ground exceptionally dry, reinforcing the desert status of the continent. To really grasp this, let's do a direct comparison: the Sahara versus Antarctica. In the Sahara Desert, dryness is driven by heat. There is a high evaporation rate due to extreme temperatures, and it receives approximately 3 to 4 inches of rain per year. Now look at Antarctica. Here, we have low evaporation due to freezing cold. Yet it receives only about 2 inches of precipitation per year. By the sheer numbers of precipitation, the frozen continent is technically drier than the burning sands of North Africa. If you were to dig beneath the snow in the few ice-free areas, you would find a very specific soil composition. Desert soil characteristics are universal. Just like in hot deserts, the soils here are often rocky, sandy, and incredibly low in organic material. In Antarctica, this soil is permanently frozen, known as permafrost, and lacks essential nutrients. Furthermore, these soils have an extremely high salt content. This salinity prevents most plant growth, creating inhospitable conditions for vegetation to establish roots, much like the salt flats of a hot desert. So what can grow in a frozen desert? Vegetation in a cold desert is scarce. You will find no trees or shrubs here, They simply cannot survive Antarctica's harsh conditions. The flora is limited to the simplest forms of life: mosses, lichens, and algae. To exist here requires incredible survival adaptations. These plants remain dormant during the long, dark winter months, effectively shutting down. Then, they photosynthesize frantically and quickly during the brief summer period when the sun never sets. Animal life faces the same struggle. We see familiar faces, but we must understand their animal adaptations. The large animals we love, like penguins and seals, are marine-based animals. They rely on the ocean for food and existence, using blubber and waterproof feathers or fur for essential insulation. They are visitors to the ice, not residents of the land. The true land animals are tiny, microscopic creatures like mites and springtails. These incredible microanimals survive the extreme cold because they have developed natural antifreeze proteins in their bodies, allowing them to exist in a deep freeze. Climatologists study the water cycle in Antarctica with fascination. In the tropics, the water cycle is fast: rain, evaporation, rain, evaporation. But here, the cycle is very slow compared to tropical regions. We have the precipitation, the ice sheet formation, the glacier calving, and the ocean. But there's a missing link. Because there is very little surface evaporation or rainfall occurring, water gets locked away for millennia. It is a slow, grinding cycle that preserves the history of our planet in layers of ice. Why does this desert matter to us? It has massive global importance. Antarctica acts as Earth's heat sink. Its vast white surface reflects sunlight back to space, a process called the albedo effect. By doing this, its white ice sheets help regulate global temperatures, keeping our planet habitable. Furthermore, it provides sea level regulation. Its massive ice sheets hold enough water that they regulate global sea levels. And for scientists, these desert conditions preserve ancient climate data in ice cores, giving us a record of Earth's atmosphere stretching back hundreds of thousands of years. For humans, survival in the desert is a constant battle. We are biologically unsuited for this place. Humans cannot survive here without imported food, fuel, and equipment. Even obtaining water is a chore. Research stations must use massive amounts of energy to melt ice to create drinking water. And oddly enough, dehydration is a major risk for explorers in this environment. You might be surrounded by ice, but the dry air sucks moisture from the body rapidly. Every breath you take expels moisture that is never replaced by the dry air around you. However, this ancient stability is under threat. We are now seeing the climate change impact. As the planet warms, we see a paradox. Warmer air holds more moisture, which is potentially increasing snowfall in some areas. But simultaneously, coastal melting is accelerating. The coastal edges are melting, turning what was once a polar desert into tundra in some areas. This brings ecosystem disruption. A disruption to the delicate dry balance threatens the unique ecosystem that has evolved to survive in the cold. So, as we conclude our journey, we return to our original question. Antarctica is a desert because it is arid, not because it is empty. It is defined by low precipitation, less than 2 inches per year. It holds extreme records. It is the coldest, windiest, and driest continent on Earth. It challenges our perceptions. It forces us to realize that a desert isn't just a place of sand and sun. It is any place where water, the essence of life, is locked away or absent. Antarctica is a frozen desert that challenges our perceptions of what deserts can be. And in its frozen silence, it tells the story of our planet's climate, past, present, and future.